Okay. A motor car traveling along a straight road with a uniform acceleration takes 5 seconds to move between 2 points 15 meters apart. If its velocity when passing through the second point is 5 meters per second, its velocity when passing through the first point is. Okay, I'll give you a minute. You can try the question. I'll start the explanation. Anyone got the answer? If you got the answer, means you can share in the chat box. You can text me the answer. Okay. So a motor car traveling along a straight road with uniform acceleration. So acceleration is constant A. Uh, takes 5 seconds to move between 2 points 15 meters apart. So I taken that 2 points as A and B 15 meters apart. If its velocity when passing through the second point is 5 meters per second, its velocity when passing through the first point is. So here we know the time, velocity, and this we can use first we can use v equals u plus at to find the acceleration. We can find the acceleration first. A equals v minus u over t. So therefore a equals, sorry, u is not given there. Alright, so here I'll apply in this direction v squared equals to u squared plus 2as. You want to find the u here. So v is 5 squared is equals to u squared plus 2 into a into displacement is 50. So therefore 5 squared is 25 equals u squared plus 30 times a. So therefore we can write u squared is equals to 25 minus 38. Yeah, so here we can directly find the initial velocity by using this equation. C equals u plus v over 2 into 10. Okay. Yes. So the displacement is 15 is equals u plus v equals u plus v. V is 5 divided by 2 into time 5 seconds. Okay, so then therefore we have 5 into 1, 5 into 3. Take this 2 to the other side, 6 equals u plus 5. Therefore u equals 1 meters per second. Okay. Guys, can you hear me? I think something went wrong with my screen. Can you hear me?
Yes, sir.
Okay, thank you. Suddenly my screen got blank from mobile device. Okay. So here when you are doing these questions, no need to draw these things and all. Okay. We should be able to understand what are the parameters given, and based on that they have to use the right equation so you can get the answer. Okay. So therefore the answer is 1 meter per second. Okay, do the next question, 22. So here we can see initial velocity is given and acceleration is given. The distance is moved during the 5 seconds of its motions. So for this, what is the equation we can use? We can use this equation. S equals ut plus half at square. So then we have s equals to initial velocity 7. 7 into time is after 5th second 5 plus half into acceleration is 4 into 5 squared. So S equals 7 into 5, 35 plus 2 into 5 squared is 25. So 50 and 35 is equals 2 into 25, 50 and 35. The initial velocity of the body moving along straight path is 7 meters per second. Its acceleration, the distance is moved during the 5th second of its motion is. Initial velocity of the body moving along straight path is 7 meters per second. The initial velocity is 7, acceleration is 4. The distance it moves during the 5th second of its motion. Okay. So here we get 35 and 50, 85. 85 meter. It's not. I think there's a problem with this question. I think it should be 85 something. This third question. Yes, Hirosh. Okay. Yeah. Right. So here, this tricky question, they're asking the distance it moves during the 5th second. So we want to find the distance it travels within the 5th second. Okay. For that, what we have to find is we can find uh, the displacement after 5 seconds and also the displacement after 4 seconds, and you can take the difference. So here is equals ut plus half at square. So x equals u is 7 into 5 plus half into 4 into 5 square. Okay, therefore x equals here 35 plus, if you simplify this, you get 50. So that is, I say this is x5. That means the displacement after physics alone. So it will be 85 meters. And then I find S4, which will be 7 into 4 plus half into 4 into time is 4 seconds, 4 squared. So S4 is equals to 7 into 4, 28 plus 2 into 16. So S4 is 2 into 16 is 32, 32 and 28, 60. So therefore, the distance traveled during the 5th second is actually is given by the difference. So 25 meters. So second one is the answer. Okay, so the answer is 25. So for these type of questions, you can get the delta S as you can write this and keep, if it's moving at constant velocity, u times let's say some time t dash minus t, okay, plus half into same acceleration, and then you get t dash square minus t square. So you can write like this also to get the displacement within that second. Because if you write this, you can straight away get the answer. Now, for example, let's say now for this question, you need to get the distance traveled during the 5th second. Therefore, it will be u is 7, here 5 minus 4 plus half into acceleration is 4 times 5 square minus 16, 4 square. So here you get 7 into 1 is 7 plus 2 into 5 square 25 minus 16. Therefore, 7 plus 2 into 25 minus 15, 9. 2 into 9, 18. 18 plus 7 is equals to 25 meter. So you can keep this in mind. I mean, you can note this. You can apply for any time gap, like the distance traveled during the within the last 2 seconds means then we have to take here 5 and here 3. So this is can be used only for the same object and different time location. Okay. Okay. Do question number 23. If there's anything wasn't clear, please don't hesitate to turn on the mic and ask. Okay. A body moves along a straight horizontal path with a uniform acceleration. It covers a distance of 30 meters during the 3rd second and a distance of 50 meters during the 5th second of its motion. The acceleration of the body is, Okay. So here it says it covers a distance of 30 meters during the third second. And a distance of 50 meters during the fifth second of motion. And you have to find the acceleration. Okay, I'll give you another 30 seconds. So this question also you have to think similar to our previous question. It's not clear to me, Hirosh. Okay, let's just. Okay, so a body moves along a straight horizontal path with uniform acceleration. First, in the third second and a distance of 50 meters during the fifth second of this motion. So I can use in this direction f equals ut plus half x plus, or else I can use this one. As I told you in the previous one, the delta is equals to u from t dash minus t plus half into a times t dash square minus t square. Okay, so here it says the distance traversed during the third seconds is 30. So 30 equals u is unknown. T dash is during the third second. So I have to take 3 minus 2 plus half into a times. Here I get uh, 3 square minus 2 square. So it will be 30 equals u plus a half to a times 3 square is 9. 9 minus 4 is 1. So here I get simply 5 over 2a plus 5 over 2 times a. So this is equation number 1. And similarly, I can write for during the fifth second, 50 equals to u times 5 minus 4 plus half into a into 5 squared is 25 minus 4 squared is 16. So here I get 50 equals u plus 25 minus 16 is 9. 9 over 2 times 8. So this is equation 2. So I can take 2 minus 1. So 50 minus 30 is 20 in the left hand side. U and U cancel. So I get 9a minus 5a divided by 2. So you can take this to the other side, or else let's keep it 4a here. 20 equals 4a divided by 2, so 2 is 2. So therefore a equals 10 meters per second square. So therefore acceleration is 10 meters per second square. Okay, so there's some typing error. Okay, actually I got these questions from which Hiro shared to me, and then I asked my typesetting person to type this everything. I had to tell that person to go through this thoroughly. No, it's talks about the same object, right? So when you start about the now here when you start the motion, t equals 0, That's the velocity. It will be same for, it's actually one object. Okay, so after, during the third and second and during the third second, it has traveled some distance, and then fifth second some distance. So u is the its initial velocity. When you start to measure that, click the stopwatch. Is that clear, Hirosh? Okay. So therefore, here the answer is 10 meters per second square. So in the book also it's like it. Okay. Hirosh, can you drop a text question number 23, put 10 minus 2 to WhatsApp so that I can edit that. Okay, and do the 24th question. Okay, try to get the answer for the 24th question. Thank you, Hirosh. That boy is absent today. Hold on. Okay, did you get the answer for the 24th question? The above. Yeah, you can do like that also. But then you will get more variables, no? By the way, I recommend you to communicate through the night. Okay. Did you all get the answer for the 24th question? Check. Can you share your workings here, Roshten? So we can see that. Okay, a balloon moving upward has a velocity of 12 meters per second when it is 80 meters above the ground level. A body which is released from the balloon at this instance will reach the ground after. Okay, did you got the answer? Anyone? Prithviraj? Okay, so a balloon moving upward has a velocity of 12 meters per second when it is 80 meters above the ground level. A body which is released from the balloon at this instant will reach the ground after. Okay, so we can use downward direction s equals ut plus half at squared. So when it reaches the ground, it may have traveled a total vertical distance of 81. Okay, and the initial velocity is 12 meters per second. It is vertically upward, so it's minus 12. So we consider the balloon that is moving upward 12 meters per second. So if you drop from the balloon, so the object, whatever the things in the balloon also have the same speed. So this one also has an initial velocity of 12 meters per second. It's upward. And this height is 81 meter. So initially what happens, it will go some height under deceleration due to gravity and then it falls back to the ground. So when we drop from here, it will travel net vertical displacement is 81 in downward. Okay, so times t and plus half into 10 into t squared. So here then we can write 81 c equals to, I take all the terms to the left, no, to the right. So I have 0 equals 5t squared minus 12t minus 81. Okay, so what are the factors of 81? So 81 is actually 9 into 9. Any other factors? 3 into, no. So I use the formula. Sorry, no. Yeah, it's easy to use the formula otherwise. So we can use the formula. T equals minus b minus 12 plus or minus b squared minus 12 squared minus 4 into 1, 5 into 4 AC. C is minus 81. Root divided by 2a, 2 into 5. So here 12 plus or minus 12 squared is 144 minus 20, minus into minus plus 81 into 20. 81 into 20. 81 into 2 is 162. 4620 square root. divided by 10. So 1620 plus 144, 4, 6, 7, 1764. So 1764 is the square number. So we want 1764 square root. Let's divide by 4. We can divide by 4. So we have 4 into 416 remains 1. So 416 again 4 remains no, okay, and then 441. Okay, so 4 into that. So this is equals to 12 plus 4 minus 4 into 441 is actually 21 squared over 10. Then we get 4 is 2 squared. 2 into 21 is 42. 42 divided by 10. So we get two solutions. For the plus case, we get 12 plus 42 is 54 divided by 10. In the minus case, it is a negative number. Negative answer we can't take. Therefore, answer is 5.4 seconds. Is that clear, everyone?
Yes, sir.
So here we can see it's a negative minus 30 divided by minus 15. So that is not acceptable. We are talking only forward in time. The answer is 5.4 seconds. Okay, let's check that. Wait. How did you take U is 30 and V is 50? I mean, if you can send the whole working, would be helpful. Here it says 30 meter when during 30 which means 1 second. No. You can't take like that. If it's moving with constant acceleration only, you can take like that. So if you use x equals ut, then the acceleration has to be 0. Then it's okay. Right now, what we are saying is you have to use this one. No? So 30 divided by 1 second. It says uniform acceleration. So acceleration doesn't mean acceleration is 0. So there is acceleration, no? Half 80 squared 7. So you can't do like that. Okay. If it's moving with constant velocity only, you can take like that. Okay. So it's you can't do like that. Okay. Okay. Do the 25th question. It's not clear to me. If you can speak up, if you can use your mic, would be helpful. Otherwise, initial therapy and final, that we can get this. How can you find initial velocity therapy and uh, not clear to me?
Sir,
You can send the word version for that. Yes.
sir, in the question it says the
Yeah.
it covers a distance of 30 meter during the third second. So we can get it as 30 meters per second, like initial velocity for that moment.
No, no, can't do like that. Now it says the 23rd question.
Yes,
It
sir.
covers the distance of 30 meter during the third second. Okay, that means t equals, now if you take this part, when the time hits during the third second. So 2 seconds from here to t equals 3 seconds. In this time, this distance is 30 meter. Okay, and then the acceleration we don't know, and it has some velocity here, and let's say u1, that is also we don't know. Here some velocity, that one also we don't know. Okay, so now from this we can't get like that, no? I mean, it covers a distance of 30 meter during the third second. Now
Okay, sir, I got it.
you can't get it like that
Yeah,
because it covers a distance of 30 meter during the third second. So here it is also actually accelerating. It has some velocity here, some velocity here. So both we don't know. So if you are going to do like this means we have to solve more variables. Okay.
okay, sir, got it now. Thank you.
If you still not clear with this, then you can contact me after the class. Okay. I'll take some time and explain. All right. Question number 25. Okay. Quickly get the answer for the 25th question. If you got the answer, means you can take to the TKI. So I can see the answers. Okay. So I got a message from Hirosh. He has went through the recording, and it seems we have done only up to question number 17. So 18, 19, 20 we haven't discussed in the last class, and today we started from 21. Therefore, right after 25th question, we'll do 18, 19, 20. Thank you, Hirosh. Okay, when a body is falling freely, the distance it falls during the last second of its motion is equal to the distance it falls during the first 3 seconds of motion. The total time of its motion is. Okay. When a body is falling freely, the distance it falls during the last second of its motion is equal to the distance it falls during the first 3 seconds of motion. So first you can find the distance it covers during the first 3 seconds by applying downward is equal to t plus half a t square. So initial velocity is 0, falling freely, which means approximately. So therefore x equals half into acceleration 10 into time after 3 seconds, so 3 square. So therefore x equals 5 into 9, 45 meter. So this 45 meter is equal to distance traveled within a second. Okay. So then that delta S we can find. So it will be the distance it was during the last second of its motion is equal to the distance it was during the first 3 seconds of motion. So in first 3 seconds it will travel 45 meters. So the same distance it will cover in the last second. Okay. So we can write half into 10 into let's say the last second is 10 and therefore the previous second is 10 minus 1. 10 into 10 square minus 10 minus 1 square. Okay. So delta S is 45 is equals to, we get 5 times n. So we can simplify this as a square minus b square. n, a square minus b square is equals to a minus b times a plus b. Right? So in that way I can simplify this. So n minus n minus 1 and then n plus n minus 1. So here if you simplify this it will be 1. Okay. So therefore we have 45 equals 5 times 2n minus 1. So here 5 into 1, 5 into 9. So 9 plus 1 equals 2n. Therefore n equals 10 divided by 2, 5 seconds. The second one is the answer. And indeed we know we wrote in the theory that the distance covers during the last second is given by 5 times 2n minus 1. So if you can remember this, you don't need to write these steps. So here then 5 times 2n minus 1 is equals to 45. So that's why you can simply solve and get the answer, which is 5 seconds. Okay. Is that clear?
Sir,
Yes.
since the distance is covered in the first 3 seconds and last second is same, can't I use 1 second, like 1 square instead of 3 square?
No. Now here it says now when we drop an object starting from t equals 0, so after 1 second it will be traveled one some distance. Actually it is 5 meter. If I'm correct. Okay.
Yeah.
You can write the equation and find that distance will be 5 meter. And then during the second, after 2 seconds, it will travel, if I'm correct, 15 meter. Sorry, 20 meter. So this total distance is 20 meter. In this time interval, it is 15 meter. Okay. And in the third second, it will travel a distance of 25 meters.
Yes.
So therefore, here 20 and 25, 45 meters. Now, if you know these things and all, then you won't write. I mean, if you have good practice with these questions, you won't even writing this. So you know, after 3 seconds, it will fall 45 meters, and then the distance traveled within a second, like it can be 10 seconds or 9 seconds, is given by this formula. Delta S equals 5 times 2n minus 1. So then you can say that this delta S is equal to 4. Okay. Did I answer to your question?
Yes, sir.
Okay. Okay, do question number 26. Sorry, we'll do question number 18, 19, 20, and we'll come back to this. Because we didn't discuss these questions. Okay, do question number 18. A ball rolling along a smooth horizontal floor rolls up a smooth inclined plane to reach a point B and then returns along the same path as shown in the figure 33. Yeah. The variation of horizontal component of the velocity of the ball with time is represented by. So here it's actually the variation of horizontal component of the velocity of the ball with time is best represented by. The variation of the horizontal component of the velocity of the ball with time is best represented by. Yeah. Will be the horizontal component here. The variation of the horizontal component of the velocity of the ball with time is best represented by. Okay. Drop your answers in the chat box. Each and every of you should send your answer. Okay, I got an answer from Hirosh. What about others? Sithira, Aisha, Akila. You can drop your answers in the chat box. Send it to the TKI. Okay, now we know during this horizontal motion, the velocity is definitely a constant, right? So therefore, the first one won't come, fourth one won't come, fifth one won't come. So it could be either second one or third one. Okay. So then what happens when it's moved to this? Okay. the velocity component, horizontal component will decrease to 0. When you come to B, it will be 0. Okay, so both fine. Correct. And then what happens? And then it will go in backward direction. Okay, so therefore, the velocity will be now negative. The horizontal component will be negative because it's moving in the opposite direction. So therefore, answer is 2. Right? Okay, so therefore, answer is 2. Here, if in case if they ask the magnitude of the horizontal component, the magnitude of the horizontal component means the answer will be third. So regardless the direction, you consider only the magnitude, how it is. Then the answer will be third one. Is that clear, guys? Okay, good. I got the correct answer from everyone. So, good. All right. Okay, question number 19. At the instant, the motor car A traveling with a uniform velocity overtakes the motor car B, which is at rest. B starts motion with an acceleration. The corresponding velocity time graph are shown in figure 35. Okay, in this figure, the time the motor car B takes to overcome motor car A is the time the motor car B takes to overcome motor car A is. Okay, I'll give you a minute to quickly do this. Okay, good. Okay, to find that, I'm going to, if I can do it, I consider the B overtakes A at time t. At time t, let's say the B car overtakes A car. Okay, so when it happens, the area under the curve will be same because both of them have same distance, have traveled same distance. So therefore, I can write 10 into t, that is the distance traveled by the car A, its area, is equals to this area, so which is half into base is t times, here the velocity value we don't know, so I say v. Okay, so v is actually v equals u plus at, so it will be acceleration is not given. No? Hold on. Half into base into v. V is actually 80. Acceleration times and starts moving with an acceleration. Okay. Okay, so here acceleration we can find from here. Okay. Okay, I will explain this again. So I assume at time t, B will overtake A. Okay. So therefore, both have covered the same distance. Sorry guys, the Zoom was disconnected in my desktop. Reconnect it. Okay. Okay, so I consider some time t, the B will overtake A. Okay, so then distance traveled by A is actually 10 into t. So this is same as the distance traveled by B. So that is half into t into V. Okay, so to find V, I can use V equals U plus AT. V equals U plus AT. So V equals A into time. A I can find from this graph. A equals the rate of change of velocity, which is 10 minus 0 divided by 20, which is half. The acceleration is half, therefore V equals half T. That's 10, yeah, 20, half. So therefore 10 into T equals, okay, so here T and T can cancel. Okay, so I cancel this T and this T equals half into half, V equals half T. So therefore T equals 40 seconds. 2 into 2, 4, 40 seconds. Okay, so fourth one is the answer. Is that clear? In this type of question, the frequent error done by the students is when they see, okay, both have here same, so they consider, okay, 20 seconds, the distance is same. No, the distance will be same when the area under the curves are equal. So assume at some time t, uh, B overtakes A. So then the area under the curve should be equal. So here this area is, the distance traveled by A is actually 10 times T. And likewise, then you can find the area that the B covered. That's a triangle, half into base is P into height V. To find V, we can use V equals U plus AT. So here A is equals to, from this you can find the gradient, the acceleration, 10 over 20 half. Therefore, V equals half T. So we get T equals 40 seconds. So after 40 seconds, B will overtake A. Okay. And question number 20. The velocity of a motor car traveling with uniform retardation reduces from 30 meters per second to 50 meters per second in 10 seconds. The further time that elapses when the motor car comes to rest is. Okay, do this question quickly. Okay, so here you can find the deceleration, right? You can use deceleration. I think you can find the acceleration, which is final velocity minus initial velocity. 15 minus 30 divided by 9. So minus 1.5 meters per second square. Okay, and then you can use this reaction v squared is equal to u squared plus 2a. No, so you want to find the time, no? Yeah, the further time that elapsed when the motor car comes to. So you can simply use v equals u plus a. So v0 initial velocity you can consider 15 plus the acceleration is minus 1.5 into time. So therefore t equals 15 divided by 1.5 is actually, so 15 divided by 1.5 equals 10 seconds. So therefore answer is 2 10. See who has got your answer. Okay, question number 26. If you got the answer, you can share it to the chat box. Okay, so here we can simply apply vertically downward s equals ut plus half at square. So s equals initial velocity 5 into time during the distance it passed during the second step. Okay, so it's during the second step. Okay, so therefore I can write here, consider like this, u t dash minus t plus 1 over 2 times 10 into t dash square minus t square. Okay, so I want the distance covered during the second step. So therefore delta s is equals u is 5 and 2 minus 1 plus 10 divided by 2 is 5. 5 into 2 squared is 4 minus 1. So 4 minus 1 during the second. So therefore delta is equal 5 plus 5 into 3 15. So it's equal to 20 meters. Okay. So the answer is second one.
So, why did you like put
Yes.
t dash minus t and
Yeah, here now this actually, okay, I'll explain. Okay, so when you drop the object with some initial velocity downward, so how do you find the time? So let's say the distance traveled after second. So it's 2, for example. So u t some time will be there. So after 2 seconds, okay, t2 minus plus half into 10 into t2 square. You will get this equation 1. Or sometimes, for example, so in general, what I can say is the displacement of the ball after some time, let's say after 5 seconds or any time. Okay? So then I can write that x is equals to u t dash plus half into 10 into t dash squared. Okay, this is the velocity of the ball after 5 seconds. So t equals, for example, 5 seconds. Okay. Now, if you want to find the displacement during the 5 seconds, so this is the during the 5th second. So this time interval is actually delta t is actually 1 second. So therefore, here the time is t equals 4 seconds. So then you have to find the displacement of this also. Now here from here to here only, yes, I have taken. Okay, let's say this is uh, I'll take this as x1 and this as x2, for example. So s2 you can again write s2 is equal to u t plus half a t squared. So this equation 2, this equation 1. So if you subtract this s1 minus s2 only, you get this the displacement during that second. It's
yes,
delta S. So therefore, delta S is actually S1 minus S2. So then you get this, to subtract that, you will get such a relationship. Because otherwise you have to write this equation 2 times now. So it will
yes, yes,
take time in your exam.
yes,
So instead of that, for such occasions, you can do like this. Do you understand?
yes, sir.
Okay. And by the way, suddenly I remembered one more short trick. I don't know whether I have done this to Hiroshi or not, but again, I'll give you this question. All of you can try it. Yeah. Uh, yes. A ball, write down this question. A ball is dropped at rest under the gravity, under gravity. No, wait. A ball is dropped. Okay. A ball is dropped at rest under gravity and another ball is which under gravity from at a certain height, at a certain height, and another ball is projected vertically downward, projected vertically downward with the velocity of For example, let's say 10 meters per second at the same instant. At the same instant. Find the distance between the two balls. Between the two balls after 3 seconds. Okay. To this question, if you got the answer means you can share it to the chat box to TKI. Let's see who can finish the question first. I still didn't get the answer from anyone. Question you could have done in 30 seconds. Okay, I give you more time. Still, I didn't get an answer from anyone. It's not a complicated question, but quite lengthy. So the distance between the two balls is it 1.5 or 2? So it can be only one distance, right? Find the distance between the two balls after 3 seconds. Four 4.5. Okay. Okay, I'll do this. Okay, so first, let's say this ball is A and this ball is B. So for the A ball, I can apply downward S equals ut plus half at squared. Okay, so therefore S1 is equals to 0 plus half into 10 into 3 squared is 9. I got another answer, 30 meter. In fact, I think that's the correct answer. Okay. For me, it will take only 2 seconds to get the answer. I will tell you how I get it. Okay. So here S1 is equal to half into 10 into 3 square, 9. So S1 is equal 5 into 3 square is 9. So S1 equals 45 meter. And likewise, I can apply for the B ball. S equals ut plus half at square. So downward S2 equals U is 10. 10 into 3 plus half into 10 into 3 squared. So S2 equals 30 plus 5 into 9, 45 meter. 5 into 9 is 45. 10 divided by 2, 5 into 9, 45. So S2 equals 75 meter. So we want delta S. Delta S is equal simply S1 minus S2 minus S1. So therefore it is is 75 minus 45. The answer is 30 meter. Okay. So this answer, I can get it without doing any calculations. Without writing anything, I can get the answer. Okay, that one I will tell you, but this method is not there. Okay, in syllabus. So here, to obtain this answer, what I can do is I can consider the relative velocity. I can consider the motion, relative motion of A. The relative motion of A. So, relative motion or the motion of A relative to B. Okay. So then, considering that I apply downward x equals ut plus half at square. So the displacement will be so actually this is I had to apply vertically upward because the relative motion of A relative to B A is up this much, right? So that is delta S, and then relative velocity is 10. You can write the relative velocity principle and get it will get 10 into times 3 and plus half into relative acceleration is 0 into 3. So therefore delta S is equals 30 seconds. So to do this, I can only think, okay, so I can use Relative velocity is 10. 10 into time 3, 30 is the answer. 30 meters is the answer. Okay. Did you understand this method? So no need to write anything. If in case such a MCQ you got, okay, so the relative velocity is 10 and the time is 2. So therefore, I mean this is relative initial velocity. Relative U is relative initial velocity because U is initial velocity. So relative initial velocity is 10. 10 into the time is 3. 30 meter will be the answer. Did you understand?
Understood.
Okay. Aisha and Akila, did you understand?
Yes, sir.
Okay, good. So in this method, you can do the question. I mean, it won't even takes 2 seconds, as I told you. So relative velocity is 10 initial velocity. The time is 3, 10 into 3, 30. Because both are falling under the gravity, under the same acceleration, relative acceleration will be 0. Okay. All right. For the practice, shall I give one more similar this type of question?
Okay, sir.
Okay. So write this question. Two balls A and B. By the way, this equation, this method you can apply only if both the objects are started from the same time, at the same instant. Okay. Right. Two balls A and B are projected vertically with initial velocity of projected vertically with velocity of two balls A and B are projected vertically upward. Sorry. Vertically upward with velocity of let's say 10 meters per second and 22 meters per second respectively. Find the distance between the two balls after 5 seconds. Okay, I already got an answer from a student. Very good. Seems to be the answer is correct. Good. Who has got the answer? Okay, so the answer is I actually expected others also would say very soon, but I got the answer from only one student. Now, we have some problem with multiplication. So here we can simply apply vertical upward is equals to t plus half kt square. Okay, yeah, the answer is 60 good. So the relative displacement during this time, let's say t equals 0 to t equals 5. The relative displacement, let's say delta s. The relative initial velocity is 12 into time 5 plus half into relative acceleration. Both are moving under the same gravitational acceleration, therefore relative acceleration is 0 into time 5 square. So therefore delta S equals 12 into 5, 16 meter. So simply you have to take this difference. Relative velocity is 12. 12 into time is 5, 16 meter. Okay. Actually, to get the answer, I don't even need to write this and all, but to explain only I wrote. Because this method is very strong method that you can get the answer very fast. But keep in mind, this one you can apply if the time interval for the both objects are same. Both objects are projected from the same instant. Okay. Do you have any questions, guys, regarding this? If you have any questions, you can raise it up. Okay. Do the 27th question. At time t equals 0, stone is dropped downward from the top of the hill of height h. At the same instant, another stone is projected vertically upward from the foot of the hill with the velocity v. If the stone is projected with sufficient velocity, the time elapsed when the two stones meet is. Okay. I'll give you a minute, couple of minutes to do this question. And I'll do this question in two methods, one typical method and another method. Okay. Where's got the answer? Yeah, I didn't get any more answers. Okay, so I'll stop. Take much time. All right, so here, so at some time t they will meet. So let's say the distance covered by this will be x. Okay, then the distance covered by the other particle will be h minus x. Okay, so I can apply for this vertically downward c equals ut plus half at square. So the distance covered h minus x equals u is 0 plus half into 10 into the time is capital T. The time is what we want to find. So therefore here h minus x equals 5t square. This is equation number 1. And for the other particle, we can apply vertically upward. S equals ut plus half at square. So S will be x plus vt minus 5t squared. Okay. So then is equation number 2. I want to get rid of x because x is not there, so I can substitute that here. Right. So by 1 and 2. By 1 and 2, I have h minus x is vt minus 5t squared h minus x. For the x, I put vt minus 5t squared is equals to 5t squared. So here I have h minus vt plus 5t squared is equal to 5t squared. So 5t squared cancel. So h minus vt equals to 0. So h equals vt. Therefore, t equals h over v. So t equals h over v. So the answer is the first one, no? H over v first one. Okay. So this is the typical method. Okay. So t equals h over v. The second method is the same. Now the previous two questions I gave, so relative motion I can consider because both have the same time interval, starting from same time, finishing from the same time. So I can consider the relative motion. Okay, so let's say this is A and this is D. So I consider the relative motion of A relative to B, let's say. Okay, so I consider a direction downward. Or let's say upward direction. Yeah. Or else I take B relative to motion of B relative to. Yeah. I take the motion of, okay, whatever, motion of A relative to B. Also, if you want, you can take motion of B relative to A. So, and motion of A relative to B, I assume B stop means A is moving downward, so it's downward. Yes, equals ut plus half at square. So the relative motion, they are meeting means initially the distance is h, and then after time t, the distance is 0. So therefore, during the time t, the distance covered by relative is h. And then relative initial velocity will be here, it's 0, it's v, so it's v. The time taken capital T plus half into acceleration is 0 plus, relative acceleration, both are moving under the same gravitational acceleration times t squared. So then this term is 0. So t equals h over v. See how simple. Actually, when I'm reading this question itself, I got the answer. That is t equals h over v. Okay. Did you all understand? And by the way, I would like to tell you this method I never learned anywhere. This is when I was doing questions and all. Mama actually. So you also have to do a lot of questions and practice. In fact, that is what important because if you take physics paper, you have part 1 and part 2. Part 1 MCQ 50 questions. Each question 1 mark. 40 questions correct me 40 marks. But in part 2, you have 2 papers, structured essay and essay. Now that content is big. Okay. I mean the hours that you are going to do that paper also big, but you get only 50 for that. But here, I mean MCQ, if you can score more than 40 marks, if you can keep that, that's well enough to secure A for physics. You have to maintain more than 40 MCQs. Okay. For that, you have to do more and more questions as much as possible. All right. Okay. By the way, is there anyone who did this question using this method? Let me know in the chat box. Okay, so you also done the first method. Huh? Okay, good. Anyway, but if you consider the second method, no need to write anything. Okay, without writing a panatita kliyan you can get the answer. I mean this method. If you consider this relative velocity method, okay, you can see both starting at the same instant, finishing the motion at the same instant. So we can apply this relative motion scenario. So their meeting means initially the distance between the two objects is h, and their meeting means the relative displacement is h, and the relative velocity, one is initial velocity is 0 and v, so relative velocity v. So you can just write this h equals vt, so t is hov. Okay, without spending a drop of an ink, you can get the answer. All right. Okay, question number 28. Which okay, this one I need an answer from each and every one. After that only I will respond, because this is very easy question, conceptual, and if you got wrong, this means so bad. Let's see who is giving the correct answer. Okay, I got an answer from Hirosh, and it's correct. How about others? Please send your answers. Once you get the answer, I mean, you find if this is the answer, you put that. Okay. Okay, I got another answer. Okay. Two to go. Sithira and Akela. Okay, Sithira. Okay, good. Correct. All right, so here object is going under gravity. So throughout the motion, the gravitational acceleration is vertically downward, always vertically downward, right? Towards the Earth center. G is always vertically downward. So vertically downward is the answer. The acceleration is always vertically downward. Okay, right. Good. That. Okay, do 29th question. By the way, suddenly some stories pop up into my head, so I'll share it with you. So it's a story about Einstein. So Einstein, you know, he is a great scientist. He travels to country and cities to give lectures or speech, to deliver speech. So one day, like that only, when he was traveling with his driver, um, so the driver says, "Sir, I remember." Okay, I remember all your speech because I used to listen. I can remember everything like that. So then Einstein replied, okay, is that the scene? Then the city that I'm going, no one have ever seen. Now these days only we have this advanced technology, TV, mobile phone and all, but those days newspaper only. But newspaper also not brought by every person. Like only Arab Prabhu, like rich people only with the newspapers in those days, right? Like something like that. Okay. So no one has seen Einstein in person in picture, right? So then Einstein says, okay, then let's do like this. You go and deliver the speech. I'll sit and watch. Okay. So then the driver also agreed, and he remembered all the things that Einstein used to speak, and he delivers very nicely. And the crowd also applauds to him, and he was so happy. And before he stepped down, one person came up and stand up and asked, "Sir, by the way, can you explain that how that mass will increase when a particle has a larger speed?" So now he knows only the things Einstein explained on a sudden question. Then, so it's a trouble, no? Okay. Now I'll ask you. Allah, this connection is so bad. Poddi Vessa Coindaba dialogue connections is too weak. If you know any good network, please suggest me, okay? Recommend me, okay? I am done with this. Okay, so where did I stop? Yeah. Okay, so I'll ask you a question. In such a situation, what will you do? What will you say? So if you are in that situation, what would you say? Let's see who comes with a creative answer. Hirosh, do you remember the story? So you know the answer, right? Is it? What do you mean by slash? Is it yes or no? Uh, okay. Yes, correct. By the way, I'm wondering how you text so fast. Are you using the keyboard? Not I have read the biography, but there are some series I have watched. There's one good series by that from UK. What is that name? It's a media company, not CNN. Maybe CNN, I think. Okay, so no idea. This. So the driver says, yes, genius, genius. But the production company, I forgot. Sunday Times, no, some leading media in UK. I'm getting it. Okay, all right. So the driver says, he says like this, "Ayo, this make up prashna. This is too easy. Even my driver can come and explain you." So driver, he is pointing the real Einstein. Okay. So the vice of the moral of the story is, if you spend time with wiser person, you will act wiser. So choose your friends wisely. Yeah, National Geographic. Yes, yes. Thank you. Yeah, you can share and keep. If I get time, I will read. Okay. Okay, so have you all finished this 29th question? A body is projected horizontally from the top of a roof at height 5 meters. It strikes the floor at horizontal distance 10 meters. The magnitude of the velocity of the body when it strikes the floor. Okay, so yeah, a body is projected horizontally from the top of a roof of height 5 meters. From 5 meter height, projected horizontally. So u is the velocity. So horizontal distance is 10 meter. Okay, 10 meter. So we want to find u. So this one first we can find the time by applying vertically downward. That's equals ut plus half at squared. So the displacement is 5 equals 0 plus half into acceleration is downward 10 and the time t squared. So then here 5 t equals 1 seconds, right? 5 and 5 cancel, yeah, t equals 1 second square root of 1. So then we can use this direction is equals ut. So 10 equals u into 1. So therefore u equals 10 meters per second. So the answer is second. Okay. Okay, so here, yes. Okay. Okay, so with that, let's conclude the session for today. So time is right. If you have any questions regarding today's discussion or any other questions, you can ask me. Don't hesitate, whatever it is. I'm okay to take more time and explain. It's totally fine. I love doing this paper class. I love solving physics problems. So, yeah. Any questions, guys? Okay, you want to explain this question again? A body is projected horizontally from the top of a roof. So a roof of height 5 meter is projected horizontally. Okay, so it will travel such a path and hit the ground. Okay, so it says the horizontal distance is 10 meter. Okay, so the magnitude of the velocity of the body when it strikes the floor. Okay, so first we can apply vertically downward s equals ut plus half at squared. So the vertical displacement is 5, initial velocity is 0 times half into 10 into t squared. So if you simplify t, you get 1. And then you can consider the horizontal component is constant, right? It won't change throughout the motion because there is no any force acting on the horizontal direction. So according to Newton's first law, this velocity component remains constant. Okay, so therefore it's a zero acceleration. So half at squared times 1 term is only s equals ut. So then the displacement is 10, u is I'm considering for the horizontal direction. So we consider the horizontal component is throughout the motion constant. So that is u times the time is 1 second. Therefore, u equals 10 meters per second. Is that clear, Hirosh? Is it clear?
So, but
Yeah,
how-
it's horizontal direction. Okay. So now, yeah, I'm using this because this object, when this object reach here, the same time, right? So here time equals 0 and here time t equals capital or simple T. That's what we have found. No, we don't have to find they're asking the magnitude of the velocity of the body when it's, yeah. Sorry. Actually, I read the question wrong. I thought we want to find this u, but the thing is the magnitude of the velocity of the body when it strikes the floor. So I want to find here this v. Okay, so that's why we had to read the question carefully. So it's my mistake. I didn't read the question carefully. Okay, so here then this component is 10, and then vertical component we can use simply v equals u plus at because we know the time. So initially this component, let's say w. So w, I take this component w equals 0 plus 10 into 1. So w equals 10. So therefore this is also 10. So 10 square plus 10 square root is 10 root 2 meters per second. Okay, thank you, Gurash. So the answer is 10 square plus 10 square is 200 square root 10 root 2. There is no answer again. Yeah, I think that book has some typing mistake, or else is the mistake. Is it there in the book, or maybe the mistake is done by our typesetting? Okay, so anyway, the answer is here 10 root 2 meters per second. Mistakes in the books. Okay, so there is no mistake done by our typist. Okay.
so like, are we finding resultant velocity because this is projectile motion?
Yes, here when this hit the ground, it has overall velocity in this direction. So, but we know we normally describe the projectile motion considering the two perpendicular components, horizontal component and vertical components.
Yes.
So the horizontal component is throughout the motion constant, now it's 10.
Yes.
Is it clear?
Yes.
And then the vertical component we have to find initially 0. We can use vertical downward. V equals u plus at. So this component, let's say it's w. So final velocity is w. Initially 0 plus 10 into time taken is 1 second. So
Yes.
therefore w equals 10. So
Yes.
therefore this is 10 and this is also 10. So we know the resultant of two perpendicular vectors we take as vx squared plus vy square root, no?
Yes.
So therefore here 10 square plus 10 square root. So it will be 10 root 2 meters per second to simplify. Okay.
Okay, sir.
All right. Any more questions?
No, sir. Thank you.
Okay then. So let's find out the class then. Study well, do more questions. By the way, if you find any question difficult and you need thorough explanation, or if you don't understand how to do a question, means you can share that question to the paper class group. Okay, you can share it to the group, or else you can like if you don't want to share it to the group, you can share it to me asking share it to the group. But rather, why you can directly share it to the group, so we can discuss those questions in the our paper class group itself. Because we had to focus on questions which are more difficult. Now here today we discuss around, let's say, 15 questions. So out of that, 7 question you might all know. So that time is in vain. So rather than those questions, we mainly focus on questions which are difficult for you. Okay. So therefore, if you find any question difficult, you can share it. Okay. All right then. So good night. Study well. Take care. See you all. Bye.
Good night, sir.
Thank you, sir. Goodbye.